Okay, so again we are doing the same problem of climbing stairs, but this time we are using the approach of basically tabulation. So we can assume that we are basically maintaining a DP array which would store our um, results. For example, I can say that suppose this is my DP array which I have created, and I am traversing from this to this direction. Basically, this is index 0 and this is n. So I know that if I would reach basically nth position or n minus 1th position, so I need to return 1 from there, because if I am already at here, so there is only one way that I can stay at nth position by not moving. So that's why we would store 1 here, and at n minus 1th position also there is only one way that we can travel, only one step. So that's why I would add 1 here. For rest of the cases, for example, for this cases, I need to add both of them. Then for this case, for example, for this case, basically I would need to add both of these value. Then for this case, I would need to add basically both of these values. So this is basically tabulation, that we are having a table in which we are storing each values. So the approach is something like this, that first of all we are creating a DP array of n plus 1 size, and we are already filling it, the nth position and the n minus 1th position, to be as 1. Then we initialize the loop from n minus 1th position to when I is greater than or equals to 0, and we are keep decrementing the value of I. Again, we have initialized a value 1 and a value 2, which would basically mark the movement of our climbing stairs. Basically, one for one movement is allowed, and for here, two movement is allowed. So, um, so basically, when we would move one steps, so we would basically call dp of I plus 1, and when we would move two steps, so we would call dp of I plus 2. We would add them and store it in our current dp value. But just to ensure that we don't basically go out of bound, we have put this condition here, that we are calculating I plus 1. So what if we start from n minus 1th position? I plus 1, basically I is n minus 1 and plus 1 would be nth step, so it should be less than n step, n, because we have already initialized that value as 1. So nth step should be taken, not n plus, I mean it should not exceed the value of n. That's what we are ensuring here again. Okay, then we are just adding them and returning. So at the end we would see that the last value would contain all the distinct cases. So that's why we are returning dp of 0 as our final answer. It is getting accepted and it has submitted, so here it is done now.